Hi, it's Miss Lauschke. I'm going to do 6, 7, 8, maybe 9 from the 1.5 homework. So the first one is the cubic function, and we are using this as our translation function. So what we have here is HK is over 2 and down 2. So we're going to write y equals a times x minus a minus 2 cubed, and then minus 2. 2 to the left and 2 down. And then we're going to put a point in, the point -1, -4. So -4, this is -1. I'm going to add 2 to both sides. And my a is -2. Now this negative on the a is going to account for the reflection, okay? Because notice that it's not going the same way as the parent function. It has been reflected. That negative on the a will take care of that reflection. Okay, so there's that one. We got a domain, -infinity to +infinity, and a range, -infinity to +infinity. The next one, we've got our HK is going to be 0, -3. Okay, so for that one, y equals a times, this is going to be x minus 0 cubed, and then minus 3. So y equals a x cubed minus 3, because you don't need x minus 0. I just wanted to show you how it worked. And then we're going to pick a point, and let's pick the point 3, 6. Sorry. I'm going to add 3 to both sides and take my 3 cubed, divide by 27, and reduce. So for this one, our a is 1/3, so that's going to give us 1/3 times x cubed minus 3, and our domain, -infinity to +infinity, our range, -infinity to +infinity. All right. Number 7 is the cube root function. So our point that everything is based on is this point right here on the parent function, and it's corresponding to this point here. So I'm going right 1 and down 2. So we'll start with our y equals a times x minus h, and then the cube root of that, plus k. So y equals a, and then we've got cube root of x minus 2. That's not right. Minus 1. It's down 2. Sorry. Minus 1, because it's to the right 1, and then down 2. And now we're going to put a point in. How about the point 2, 0? I'm going to add 2 to both sides. And I've got a times the cube root of 1. So that's just a is 2. So now we can rewrite it. We've got our 2 times the cube root of x minus 1, and then minus 2. Our domain is -infinity to +infinity. Our range, -infinity to +infinity. Okay, so now I'm going to erase this one up here and do 7c. And we're going to start out with y equals a times the cube root of x minus h plus k. Y equals a times the cube root of, this one is over to the left 2, so x minus a minus 2. And then we are up 3, so positive 3. And remember, we were looking at this point right here, over to the left 2 and up 3. And now we're going to use a point. I think I will use the point negative 10, 2. I'm going to go ahead and move that 3 over. Negative 1 equals a times the cube root of negative 8. And we know that the cube root of negative 8 is negative 2. And so when I divide by negative 2, I see that my a is 1/2. So that's going to be 1/2. Oops, I accidentally put 1/3. 1/2 times the cube root of x plus 2 plus 3. Our domain, negative infinity to positive infinity, and our range, negative infinity to positive infinity. Okay, and then now we've got our rational function, and our middle is not a point on the function. It is like the midpoint of that area. So this midpoint, you can see from 0, 0, it went over to the left 3 and down 3. So for that one, we have y equals a over x minus a minus 3 and then minus 3. And then we'll put a point in. One of our points is negative 4, negative 2. And so, well, actually, I think I'm going to add 3 to both sides first. Let me erase that. So 1 equals a over negative 1. And multiply by negative 1 on both sides. And our a is negative 1. So this is going to be negative 1 over x plus 3 minus 3. Now, if you want, you can add those. So if you've got negative 1 over x plus 3 minus 3 over 1, you can multiply and get a common denominator and then add all of your numerators over the one denominator, giving you negative 1 minus 3x minus 9 over x plus 3, which is negative 10 minus 3x over x plus 3. Or you could have put negative 3x minus 10. So for this one, we could say, or g of x could be negative 3x minus 10 over x plus 3. Okay, that's another way to write it. Our domain is going to be everything except for negative 3. So negative infinity to negative 3 union negative 3 to infinity. And our range is going to be everything but negative 3. So negative infinity to negative 3 union negative 3 to infinity. And for 8c, we'll look and see that that midpoint from 0, 0 is right 2 and up 3. Oops. So we'll start out y equals a over x, and if I'm going right 2, so it's x minus 2 and up 3, it's going to look like that. And then we pick another point, and we could pick the point 1, 1. So if I pick the point 1, 1, I'm going to subtract 3 from both sides, multiply by negative 1 on both sides, and my a is 2. So that is going to give me 2 over x minus 2 plus 3. So 2 over x minus, what did I say? X minus 2, yeah, plus 3 over 1, and I multiply by x minus 2. I get 2 plus 3 times x minus 2 all over x minus 2. 2 plus 3x minus 6 all over x minus 2. 3x minus 4 over x minus 2 would be the other way to write that. So I could say, or h of x equals 3x minus 4 over x minus 2. My domain is everything except 2. See how that's the only x that I'm not going to have. So negative infinity to 2, union 2 to infinity. And then my y is everything except for that 3. Right there, that y value is the only one that you're not going to have. Negative infinity to 3, union 3 to infinity. And so that leaves